Hello everyone, welcome back. In this video we're going to learn about 2D plotting. So we're going to go ahead and start with the same standard imports as last time from matplotlib. Import pyplot as plt, and then we're going to import numpy as np. So our first example is we're going to make a two-dimensional plot of the function z is equal to sine of x plus cosine of y. So to start off, we're going to set let x be np.linspace, 0 going up to 2 pi, and we're going to grab 101 points, and then y will be the same. And I misspelled linspace. And now we're going to create a mesh grid. And this is the trick we're going to use for creating a 2D array. So over here we do x comma y is equal to np.meshGrid xy, lowercase. And to look at this, we're going to say fig x equals plt.subplots 1, 2. x0 dot imshow. Imshow is our main function for looking at 2D images. x0 dot imshow x, x1 dot imshow y. So we can see we have a plot of capital X, a plot of capital Y. Capital X changes from left to right, and capital Y changes from top to bottom. Now, we just compute the function values just by saying that z is equal to np sine of x plus np.cos of y. We then create a new figure to plot z on, so we can do fig x equals plt.subplots 1. We're only plotting one thing this time. And now to show z, we're going to do im equals x.imshow of z. And we're going to get a color bar by typing plt.colorbar im. And so, lo and behold, we get a nice, beautiful plot of z is equal to x plus sine of y. So our next example is going to be the Mandelbrot set. And for those of you guys who aren't familiar, this is going to be a self-similar shape called a fractal. Now here the math is a little bit tricky, but the idea is that you can construct a beautiful self-similar pattern through an iterative scheme. So we're going to start off by taking x and y to be linearly spaced points. We're going to use a little bit of a finer resolution this time. We're going to create a mesh grid in exactly the same way. Note you have my permission not to type right now if you don't want to. Then we let c be equal to y plus I times x, where I is the square root of -1. Imaginary numbers in Python are use j instead of I, so you do x times 1j to make x imaginary. We initialize to a dummy value of z to be 0, and then iteratively we apply the scheme of z is equal to z squared plus c. Don't worry about the overflow warning. But now we can plot this. So we got fig x is equal to a subplot. It turns out that the proper fig size to make this look nice is going to be 10 by 10. And we're actually only going to want to plot the absolute value. We're not going to want to plot the real and the imaginary parts. And to make things look a little bit fancy, we set interpolation to none, and we set the axis off to turn off the surrounding frame. And let's take a look at what we get. Lo and behold, we get the Mandelbrot set. And what's particularly cool is it's completely self-similar. So you see, here's the big picture, and then this thing is like a mirror copy of the little picture. And then this thing here is like a little copy of the whole picture. And then so is this thing on top of this thing. And it completely repeats with like layers on top of layers. It's a multi-layer fractal. All right. So now we are getting to the part where you're required to start typing again. And this is because we're now getting to the most important part of the class, which is playing with images of my dog. By far and away the most important part. Okay, so for this we need to import matplotlib.image as mpimg. And we're going to set img to be equal to mpimg.imread troy.jpg. IMG, not IMP. No imps here. And we can look at the shape. And lo and behold, the shape's actually kind of interesting. The shape is going to be 1600 by 1199 by 3. And we'll come back to this 3 in a second. But first, let's take a look at the document. In order to do this, we do fig.x is equal to plt.subplots 1 comma fig size is equal to 6 times 4.5 x.imshow image fig.subtitle. Okay, it's going to be a photo of my dog, so we can go with the title of Who's a Good Boy. Alrighty. So we got a nice good photo of Troy. He's on the lake. He's outside, breathing in the fresh air. Good doggy. Okay, now back to shapes. Okay, so the 1600 means that there's 1600 pixels going from top to bottom. The 1199 means there's 1199 pixels going this way. The 3 is a little bit trickier. What the 3 is what's called an RGB score. Typically, all colors can be expressed as a superposition of red, green, and blue, RGB. And basically, they store these 3 things separately. So in order to explore that a little bit more, we can actually separate out the RGB scores. So to do that, we're going to plot basically the exact same thing. But what I'm going to do is I'm only going to plot the third part. So this is only going to be the blue pixels. And okay, since this is going to only be the blue pixels, we can say who's a blue dog. Alrighty. And this is actually a little bit different than you expect because you see you got this yellow and stuff there. But this is just focusing in on the blue part of the RGB score. And instead we can focus in on the red part. And there that looks kind of weird. And now here's the green part. And so these are the 3 separate parts of the picture, and we can all separate them out. I'm going to go back to 2 so that matches my notes. And what this means is that we can also use NumPy as kind of a do-it-yourself Photoshop. So if we're going to do that, we need to first make a copy. So we do new image is equal to np.copy img. And now we can do new image ::2 is equal to the image ::2, and we'll make this channel twice as prominent. And we can have new image ::0 equal to, let's just make it a little bit less prominent than it was before. And now we do the same as before. We type in fig.x equals plt.subplots 1 fig size is equal to, what did I say, 6 and 4.5. x.imshow, new image. And we can add a nice title. And, oh, I misspelled, it should be new img. And now we've made our nice little do-it-yourself Instagram photo, which doesn't quite look as nice as it did when I did it in my notes. Let's see. Let's make it a little bluer. There, that's better. Now we got a nice, good do-it-yourself Instagram photo of Troy with a nice yellow sky. And we can now post that to Instagram. Okay, let's play around with this a little bit more. The video is officially over. I'm just going to mess around and play with photos of my dog. You guys are encouraged to continue to also mess around with this. Let's see what happens if we switch two of the channels. I have not done this before. I am live messing around because I am bored while filming this video. Okay. So we're just like switching the roles of the R and the G channel. Let's see how this looks. Oh, that looks funky. All right, I'm going to stop now, but enjoy the rest of your day. I'll see you guys again next time.